1.4, we are doing more review of quadratics. So here we have a quadratic equation we need to solve. So we factor two numbers that multiply to be 10 and add to be 7. X plus 3 and x plus 7. We set each of those equal to 0. Subtract the 3, subtract the 7. So negative 3 and negative 7 are my roots. The syllabus is an assignment. So you just go into the assignments and then you type your name. So, all right. Do you want to see another one of these? Or you remember how to do these? How about I do a different one? X squared minus x minus 56. I'm looking for two numbers. So this is equal 0. Wow, that was pretty. Two numbers that multiply to be negative 56 and add to be negative 1. Negative 8 and positive 7. And then we set each of these equal to 0. And we get x equals 8 and negative 7. Pretty straightforward. So here it's already set up, z plus 9 and z minus 6. So my roots are going to be negative 9 and 6. Again, hopefully this is all review. So here we want to find the zeros, which is just solving. So we have x plus 6 and x plus 4. So the roots are negative 6 and negative 4. All right. Same idea here, but I need to multiply v minus 5 times itself. Can you guys do that in your head? It's going to be v squared. Oh, is it v squared plus 25? That's most of it, but we're missing something. If we have, if we write it out, here is my v squared, and here is my plus 25. But I'm going to have two copies of this. One of them comes from v times negative 5, and the other one comes from negative 5 times v. So it's minus 10v plus 25. Okay. And that's equal to 2v squared minus 12v plus 1. Now what should I do? Move everything to one side. Does it matter which side? No. Which side would be easier? The right side. Why do we prefer the right side? We want our v squared term to be positive. If it's negative, then we just go through and times everything by negative 1. But ideally, we want the v squared term to be positive because I haven't taught you nobody's taught you how to factor with a negative leading coefficient. So subtract v squared, add 10v, and subtract 25. And that will give me v squared minus 2v minus 24. And that is v minus 6 and v plus 4. So v is 6 and negative 4. All right. Okay. Okay. I'm going to add the 4 to the other side, and I get 3y squared plus 13y plus 4 equals 0. I really, really like it when I can divide by 3, but that's a bad idea in this case because I will end up with fractions. So whenever there is a leading coefficient that is not 1, factoring is a little bit harder. And it guarantees, if this factors, then at least one of the roots will be a fraction. So if it doesn't factor, then it could have no solution, no real solution, or an irrational solution. But if this does factor, then at least one of the roots is a fraction. Okay. Now, some of you learned from Christy how to do this. Is the way that I learned when I was in high school. In my opinion, it's slow and it's easy to make a mistake. So if you know how to do it a certain way, great. If you want to learn a different way, this way always works and there's no guessing and it's hard to make a mistake. So here's what I do. Anytime there's a leading coefficient other than 1, then I build the multiplication box. Remember when you used to do this? And used to multiply them all together? Great. So if you still do that, then this will make a lot of sense. We're just going to go backwards. We know what goes in the box. We need to figure out what's on the outside. So 3y squared goes in the box, and 4 goes in the box. So I stuck this in there, and I stuck this in there. The other two boxes take a little bit of work. So here's what we do. We multiply those together. 12y squared. And then I write down all the factors of 12. 1 and 12, 2 and 6, 3 and 4. Can I use one of those sets to build a 13y? 12 and 1. But it's got to be a positive 1 and a positive 12. That's not quite enough. 1 times 12 is 12. I need 12y squared. So 1y and 12y. And that will always be the case. So these are the numbers that go in the remaining two boxes, and where you put them doesn't matter. So 1y and 12y. And now we just factor. What does the top row have in common? A y. Okay? And then whatever number goes here has to multiply by y to equal 3y squared. So this would be 3y. And then whatever goes here has to multiply by y to equal 1y. That would be plus 1. And then whatever number goes here has to multiply by 3y to equal 12y. So that would be 4. So my factors are y plus 4 and 3y plus 1. What are the roots? Well, I write equals 0 on each of those. The first one is simply negative 4. How do I solve the second one? Subtract the 1, divide by 3, negative 1/3. And I told you that at least one of the answers was going to be a fraction. Now, if you can solve these another way, great. If you don't want to use this method, that's fine. But the way I learned it in high school, I don't like. This makes so much more sense. And it's so much easier in my mind. But I guess if you want to do things the hard way, be my guest. Let's do another one. Okay. Nope. 5w squared minus 7w minus 6. I can't divide the 5 without creating a fraction. So I draw the box. I stick in the first one and the last one. And then I build a negative 30w squared by multiplying those two numbers together. Okay. Now I'm looking for the factors of negative 30 that add to be 7. So 1 and 30, 2 and 15, 3 and 10, 4 doesn't work, 5 and 6. Can I use one of those sets to create a negative 30 and a negative 7? It would be positive 3y and negative 10y. Then I throw those in the other two squares, negative 10y and 3y. What does the top, oh, these are not Y's, they're W's. I'm sorry. What does the top row share? A 5 and a W. I knew what you meant. So 5W. What times 5W is 5W squared? W. And what times 5W is negative 10W? Negative 2. And what times W is 3W? 3. So one of my factors is W minus 2. So W equals 2. And the other is 5W plus 3 equals 0. Subtract 3 and divide by 5. So negative 3/5. And again, if you can solve that using a different method, go ahead. I'll just think you're dumb. Okay. How about this one? We could divide by 6. Now, is that going to change the graph? Yes. But it won't change the roots. So this quadratic looks like something like this. Well, actually, it's going to be like this. Okay. Will dividing by 6 affect the graph? Absolutely. The graph will be 6 times shorter than it used to be. So now the graph looks like this. But the roots remain unchanged. So 6 is part of the graph, but it does not affect the roots. So if you multiply by a number bigger than 1, the graph gets taller. It sort of looks skinnier, but it's actually taller. If you divide by a number bigger than 1, then it gets shorter, or it looks wider. So we divide by 6, and I get y squared plus 2y equals 0. How do I factor that? Pull out a y times y plus 2, and I get my roots are, what's the root here? What number makes that 0? 0. What's the root here? Negative 2. So this graph hits the x-axis at 0 and negative 2. Did it blow your mind? So what if we had 3x squared minus 2x equals 0? Pull out an x, and I get 3x minus 2 equals 0. For every x, we just write equals 0 and solve. So this one is 0, and this one would be 2/3. Okay. What if you tried to throw that in the box? So what if I had 3x squared plus 2x, and I stuck it in the box? Well, 3x squared goes here. What would this be? 0. So I would get 0x squared, which kind of creates a little bit of a problem, right? What are two numbers that multiply together to be 0x? Well, there are lots of them. 0 times 1, 0 times 2, 0 times 3, 0 times 4, 0 times 5. But it needs to add to 2x. So of all the 0 times 1s and 0 times 2s and 0 times 3, when I add them together, I need to get 2. So 2x and 0. So this would be, pull out an x, 3x plus 2, and 0. So it works. X equals 0, and x equals negative 2/3. So I don't recommend solving it that way. I would just pull out the x and then set each factor equal to 0. All right. What if I know the roots are 7 and 2? How do I create an equation? So I know that x is equal to 7 and x is equal to 2. What factor would create x equals 7? X minus 7. And what factor would create x equals 2? X minus 2. Now, I want you to try to do this in your head. What is going to happen when I multiply those together? I'll do the hard part for you. X squared. And then what? You're going to get a negative 2x and a minus 7x. So it would be negative 9x. And then the constant is going to be 14. What if the 2 was negative? How would that change things? Then this would change to x plus 2, which would make what? Negative 5x minus 14. Good. Okay. All right. The area of a rectangle is 77 meters squared. The length of the rectangle is 3 meters more than twice the width. So I have a rectangle, I have a length, and I have a width. The area is 77 meters squared. How big is the length? Three meters more than twice the width. So I'm going to say that L is equal to 2W, there we go, plus 3. So I'm going to replace this with 2W plus 3. Okay? How do I find the dimensions of the rectangle? Well, area is equal to length times width, right? Or in this case, area is equal to 2W plus 3 times W, which is equal to 77. So 2W squared plus 3W, move that over, minus 77. Okay. So I draw my box. Can I divide by 2? I guess technically I can, but I don't want to. I don't want to create fractions in my equation. So we stick in the 2W and the negative 77, multiply those together, and I get negative 144. I am looking for factors of 144 that are going to differ by 3. So 1 and 144, 2 and 77, 3 and some number. Let's get a lot bigger. How about, oh, I guess I could use my calculator. Let me pull this over. All right, so let's try 144 divided by 8. That didn't work. 144 divided by 9. They differ by 5. So 144 3 more than twice the width. 2W plus 3. I'm not finding one that's going to work. 12. Well, that's not going to work. 9, 10, 11, 12. All right, guys, hold on. There's my problem. 154. Okay. 154 divided by 12. Didn't work. 154 divided by 11. There it is. 11 and 14. So I know it's 11x or 11w and 14w, but one of them needs to be negative. Which one? I want to build a positive 3, so the 11 has to be negative. What does the top row have in common? A w, and this would be 2w minus 11, and then 2w times 7 is 14w. My factors are w plus 7 equals 0, and 2w minus 11 equals 0. So I get the width is negative 7, or 11 divided by 2 is 5.5. What do you think about those answers? What do you think about the negative 7? No. Right. We want to label a rectangle. Can the width of a rectangle be negative 7? No, cannot. So we throw that away. And we know that the width is 5.5. So how do we find the length? You could times it by 2 and add 3. How else could you find it? You could use this. How would you use 77 to find the length? Divide it by 5.5. So 5.5 times 2 is 11, plus 3 is 14. So that would be the answer. Okay, so we're going to build a quadratic here, x minus 1 and x minus 5, because my roots are 1 and 5. I multiply this out, I get x squared minus 6x plus 5. How many quadratics are there that satisfy that requirement? How many different parabolas could I draw that hit the x-axis at 1 and at 5? So here's one, here's one, here's one, here's one. They're an infinite number. So this is sort of the most basic of all quadratics that satisfy that. But we want a quadratic whose leading coefficient is 3 and still hits those roots. How would I find that? Can I just put a 3 there? Everything. So I would need to do this. So 3x squared minus 18x plus 15. What did I just do to the parabola? How is it going to change shape? It's now 3 times taller. So if this was my original quadratic, this is my new quadratic, 3 times taller. The roots are the same, but the graph has changed. All right, that's it. Get to work.